The topic is of True RMS responding voltmeter. This RMS means root mean square. Okay, I hope you will be knowing of this RMS value. In your AC, you learned of how to find that value and all, right? Here also we are going the basic principle. What we are going to calculate of your voltmeter range is based on the RMS value. Okay. What is the meaning of this? The RMS value means root mean square value. Okay. How it is going to be obtained? Squaring the input signal. First we have to do the squaring of the input signal. What is the input signal means? X of t, if you are going to apply means square of that. Do the squaring of that and then take the square root of its average value. If you are taking the different values x1 of t, x2 of t, x3 of t, if you are measuring of those, take the average of that, then make the square root of that. That is how we will be getting as the RMS value. Then the RMS value is also called effective value. One more name, it's given as a effective value. What it is going for? It is doing, it compares the heating effect produced by the AC and DC. What is the use of this RMS voltmeter reading? This is giving the information about heating effect that is produced by the AC and the DC. Okay. Then the true RMS reading responding voltmeter produces a meter deflection. A deflection is going to be occurring when by sensing the heating power. Yes, by sensing the heating power, it's we are telling that heating effect, right? Sensing the heating power of the waveform, and this heating power is proportional to, observe this line, this heating power is proportional to the square of the input RMS value. Heating power is square, which is directly proportional to the square of the input RMS value. Therefore, the measurement of heating power is achieved by the use of thermocouple. How we can measure of this heating effect? We are going to use of the thermocouple. Okay, the input voltage to be measured, which one you are going to measuring of that is to be measured, is applied to the heater. That voltage we have to apply to the heater. What is this I'm telling? I will give a small example here. You'll be going to use in your homes, you're going to use your coils to heat your water. How you will be going for? You are switching your plug in the main supply, you will be taking, and your coil is connected buried into the bucket where which water you want to heat that, right? The voltage what is coming from the main, right? That much, how much the voltage is coming, right? That much heating effect is going to be uh, uh, evaporating, right, in the water. If you are heating, if you continuously switching on your coil, what about your water is going for? It is heating more and more and more, right? The same operation here also. How much the voltage you are going to give, that much heater means thermocouple is going to sense that. Okay, based on the sensing, it will be giving the readings for you. That is how it is going to be working is just in a example way I am telling you. Okay, where we stopped here, right? The input is going to measure, is applied to the heater. The heating effect of the heater is sensed by the thermocouple, right? Thermocouple attached to the heater. Then the thermocouple generates the corresponding voltage. Yes, it's going to be generating. The AC input is going to be amplified and then given to the heater element. Observe here, I'm repeating this. The AC input is amplified and then given to the heater element to achieve enough heating so that the thermocouple can generate the enough values of the level of the voltage, that is so that deflection is going to be occurring. Okay, that's what this information is giving for you. Okay, a small key point here it is given, that is the output voltage is proportional to the RMS value of the AC input. Okay, therefore for thermocouple power is equals to E square RMS value divided by R, that is resistance. It is E is your EMF value, resistance of the heater. Therefore, E naught is directly proportional to heat, voltage is directly proportional to heat, that is again directly proportional to the power. The main supply, heating effect, how much the temperature of the water, right? The same thing, depending. Then that is nothing but E naught is equals to K into E square RMS divided by R heater, resistance of the heater. Then E RMS is nothing but RMS value of an AC input. Then E naught is the output voltage of the thermocouple. K here it is taken as constant of proportionality. Okay. Then the value of K, this K depends on the distance between the heater and the thermocouple. What distance you are going to connect heater and the thermocouple, and also on the materials. The K value depends on the distance between the heater and thermocouple, and also the materials used in the heater and the thermocouple, which materials you are going to use. Okay, based on those factors, the K value is depending. Next, the main difficulty in such meter, it is of a non-linear. What it is discussed, it is of a non-linear characteristics of a thermocouple. In some instruments, this is very difficult to overcome by placing two thermocouples in the same terminal environment. It is somewhat difficult when I am going to place two thermocouples in the same environment. The effect of nonlinear behavior of the input thermocouple is cancelled by, observe here this line, is it's going to be cancelled by nonlinear effect caused by the thermocouple in the feedback path. What I am going for, I am giving one feedback for the same environment, thermal environment, where do you going to connect. Okay, the input thermocouple is called the measuring thermocouple. Now you observe the figure here. This is one thermocouple and this is one more thermocouple. The first one what it is connected is called as the measuring thermocouple, while the thermocouple which is in the feedback path, which is in the feedback path, this is this feedback path, right? Feedback current is taken, that is called as the balancing thermocouple. This is the shown in the figure. In this it is having the AC amplifiers. I hope we already come across why we need of amplifier, right? AC amplifier, we are providing then AC input. These two are heating elements in the same thermal environment. To avoid this, a feedback it's going to be given, that is taken as a balancing thermocouple. The measuring thermocouple here it is connected, that is taken as V1, here it is taken as V2, and one more here it is AC amplifier. After this we are going to use of the DC amplifier, and this is your indicating meter. Okay, then the two thermocouples balancing and measuring forms a balance bridge in the input circuit of the DC amplifier. In the DC amplifier, these both are balance bridge, it's working like that. Okay, then when the AC input is going to be applied, measuring thermocouple, the measuring thermocouple produces the voltage. Measuring thermocouple means the V1, right? This, the measuring thermocouple produces the voltage V1, which upsets the balance when it is input is provided. We are already come across when a bridge is going to be unbalanced, right? The same operation here is going to be used, which upsets the balance of the bridge. Then the DC amplifier amplifies the unbalanced voltage, and this amplified voltage is feedback from V1. Bridge is in a unbalanced condition, And DC amplifier, it's going to be it's trying to balance the bridge connection in between of these, right? The same thing here it is given. The DC amplifier amplifies the unbalanced voltage. This amplified voltage is going to be feedback to the balancing thermocouple, which heats the heater element. From this heater balanced thermocouple, it's going to give the voltage of V2. That is what here it is taken. Heater element to produces the V2 such that the balance of the bridge is re-established. What things we learned? Input is applied. Due to the input, thermocouple measuring thermocouple measures the voltage V1. Due to this, a bridge is going to be unbalanced, and DC amplifier amplifies the signal. And what is the unbalanced parameter? That is going to be fed back. When it is feeding back in terms of a current, again the bridge is in the balanced condition. That is how balancing the bridge means by using of two thermocouples. Thus, the DC feedback current is the current which is producing the same heating effect. Observe here, DC feedback current, what is coming from the DC amplifier, right? This DC amplifier is the same heating effect as that of the AC input current. What is the difference is going for? That is what we applied. It will be same. AC input current, that is the DC current, is nothing but the RMS value of the input current. The meter deflection is thus proportional to RMS or else effective value of the AC input. Okay, this is how we have to write the theory for this. Next is small derivation. In terms mathematically how we can represent, that is output voltage is equals to A into the difference between the two voltages, that is V1 minus V2, where A is the high gain of the DC amplifier. Then what is the difference? V1 minus V2 is equals to V out divided by A, that is nearly equals to 0. When it is going to be 0? As A is very higher value. Okay, in balanced condition of bridge, as and as A is very high, when it is where A is very high and bridge is in a balanced condition, then V1 is equals to V2. Then V1 is going to be output of the measuring thermocouple, and V2 is the output of the balancing thermocouple. Therefore, V1 is equals to what? K into ERMS square. ERMS is nothing but RMS value of the input. Then V2 is equals to K into V out square. That is output. V0 is the output DC voltage. Therefore, as K is same due to same thermal environment used for the two thermocouples. Therefore, E RMS square is equals to V out V not out square. Therefore, V output voltage is equals to E RMS. Means what is the change that is going to occur here due to the thermocouples? That is nothing but the deflection what is going to occur in the indicating meter. That's what V out is equals to ERMS. Therefore, the voltage measured by the meter is RMS value of an input, AC input, what is going to be provided. Okay, this is about the True RMS responding voltmeter. This question, it will be asking for 6 marks or else 8 marks question. Okay, then what are the advantages? Why we need of using of this? The first one here is of the nonlinear behavior is avoided by using of the two thermocouples placed in the same thermal environment. That is the main one advantage. Then second one is the true RMS value measured is independent of the waveform of the AC input. Correct? Are we going to measure any AC there? No, it is in terms of DC. As you observe in the diagram, you will be getting of it. The true RMS value measure is independent of the waveform of the AC input. If the peak amplitude of the AC input is within the dynamic range of the AC amplifier. Within this range means then it is independent. Okay. Then sensitivities in the millivolt. Sensitivity in terms of a millivolt region is possible. The voltage throughout the range is going to be taken as 100 microvolts to 300 volts within a frequency range of the frequencies of 10 hertz to 10 megahertz can be measured with good instrument. They are somewhat sensitive is very uh, use parameter in any of the electrical devices, right? The frequency range it should be in a proper fashion so that what is the output you will be getting it should be in a proper value for that reason. Okay, here it is taken 10 hertz to 10 megahertz we can go for that too for the good instruments only. Okay, then the response of thermocouples is slow, hence the overall response of the meter is sluggish, means it's not even giving a proper value for you. Okay, similarly, in the crest factor puts the limitations on the meter reading in case of highly nonlinear waveforms. This is one factor. Okay, the meter cost is high compared to the average and peak responding meters. The meter cost is high based on comparing the average and the peak responding meters. And typical laboratory type RMS responding voltmeter provides the accurate RMS reading of complex waveforms having a crest factor, that is crest factor is here it is taken ratio of the maximum to the RMS value, that is of 10 to 1 ratio. So just you can write the 3 points, that will be enough. If you remember, if you're able to write this, you can write up that information. Okay, this is all about the true RMS responding voltmeter. Next topic is of unlearn electronic multimeters. Electronic multimeter. This is the they are using of this instrument, and nowadays somewhat it's modified, right? For the measurement of DC as well as AC, we can done by using of the electronic multimeters, and also we can measure the current, resistance, and it is going to be used. This is also known as voltage ohm meter. That means voltage, resistance, and also current we can measure from this. For that reason, ohm meter also it is going to be called, or else the multimeter it's going to be calling. Okay, and this is an example. Just a figure it is shown. Some features of the multimeters are given here. The first one is of the basic circuit of the ohm meter includes the balance bridge. Observe here what we learnt in the first module, that is only here it is going to be used. Balance bridge of DC amplifier, and second one is to limit the magnitude of the input signal. Magnitude of the input signal. Range switch is provided. Yes, a range switch is provided by properly adjusting input attenuator. Properly adjusting the input attenuator, input signal can be limited. The range you will be changing, right? That one. And the third one is it is also includes the rectifier section, which converts the rectifiers converts the AC input signal to the DC voltage. Okay, then fourth one is it facilitates the resistance measurement with the help of the internal battery facilitates the resistance measurement with the help of internal battery and additional circuitry. And fifth one is of the various parameters measurement is possible by selecting the required using of the function switch, means which one you are going to measure you can use of that. And the last one is of the measurement of various parameters is indicated with the help of the indicating meter. And next point, a multimeter measures AC and also DC voltage, AC and DC current and also of the resistance. Now we will go with one by one. Multimeter in terms of DC voltage measurement. This is the construction voltage measurement it's going for in terms of a DC. A input you are going to provide where you are connecting plus and minus, and here is the meter reading, and internal connection is like this. A series resistance R1, R2, R3, R4 and R5. Okay, here the switch will be connected based on the input what you are going to apply and the range what you are going to fix. Based on that your meter is going to be reading the value. Okay, now we will go with the theory part. Is first is of how the construction is going for, then for getting different ranges of the voltages, series resistance are connected in series which can be put in the circuit with the range selector switch. Range selector, if you are changing to the range 1 to 10 means it may go for where you should change, the switch should change to the in between of this R4 and R5, within this in between of this. Okay, in between of this the switch is connected. How much it is measuring, that value it will go indicating in the meter. Next, we get different ranges to measure the DC voltage by selecting the proper resistance in series with this basic meter. This is how you have to measure. This is the how internal connection is going to be done in the multimeter. Then if I am going to use of the multimeter as an ammeter, this is the connection. In this it is in a parallel connection. Here it is in series, here it is going to be in a parallel connection. Just you observe R1, R2, R3 is here, R4, R5 and R6. And here the range is, when it is of ranging from 50 milliamps to 250, the switch should be connected in of this range selector switch. Then in between of 250 to 500, the range switch is going to be fixing here. It will be automatically changing itself. Okay. Then to get different current ranges, different shunts, right, parallel connections are connected across the meter with the help of the range selector switch. With the help of the range selector switch, the working is same as of the PMC ammeter. Okay, the figure is shown in the figure. Then the multimeter measurement in terms of the AC voltage. Observe here, we are going to here fixing with the rectifier. Construction is shown in figure. It's almost similar to your DC voltage measurement, the same series connection. If you just check here up to this it will be same, only rectifier thing is added here. What is the use of the rectifier? It is going to be used in the circuit, rectifies the AC voltage into the DC voltage for the measurement of AC voltage before current passes through the meter. Only extra connection is of your rectifiers. Then meter is going to be calibrated such that it gives the RMS value of the AC voltage to be measured. Meter is going to be calibrated, some changes are going to be done, so it will be measuring of the RMS value of the AC voltage to be measured. Then the other diodes we can use, other diodes we can use here for the protection of purpose. Okay, next, use of the multimeter in terms of your resistance. Here it is, the range is fixed. Here also the resistance are connected in series, R1 R2 up to R4, and R4 is the zero adjusting. Here a battery is connected. Resistance, which one you have to measure, we have to connect across this, and meter is connected. The reading is going to be measured from this. Figure is shown in figure. The multimeter for the scale multiplication of 1. Multiplication what's going for, it will be 1 only. Before any measurement is made, before any measurement you are going to make, the instrument is shorted. Instrument is shorted and zero adjusted. It should be at a zero position. Zero adjust control is varied until the meter reads the zero resistance. Means when you put at zero, means you should read the zero value only, and then it shows the full scale current. Then now the circuit takes the form of a variation of a shunt type ohm meter. The scale multiplication, it is in terms of 100 to 10,000, can also be used for the measurement of high resistance values. Voltages are going to be applied to the circuit with the help of the battery. With the help of the battery, when the multimeter is in the resistance measuring mode, when multimeter is at, showing the values for the resistance, a battery within a multimeter automatically gets connected. Okay, in it with multimeter a battery is there, that is automatically gets connected when you are going to measuring the resistance, which makes the current flow through the externally connected resistance to be measured. A current will be flowing, and which one extra, where you are going to connect it, that value you have to reading. The multimeter only senses this current based on the current with its dial calibrated in terms of the resistance. Means in the when you are going to measure resistance value, first it will be measuring the current. Based on the current, what is the resistance, it will be giving the information. Okay, this is about your how a multimeter internally connection are there, and here this you have to draw the figures properly for each parameters. Okay. Okay, from this we'll stop here.